I want to talk about the Bristol Channel. So this is a topography here, obviously, and then the bathymetry in some detail. And you can see the Severn cutting right the way down through here into quite deep water. So that's 55 meters of water depth there. So this is an ice age thing from the last stage of the ice age, when the water was 120 meters lower, and you had incision of the combined Severn and Wye and anything else coming into it, cutting down through here. And there's been some beautiful stuff released recently. So this is another image of that. Again, there's our river channel cutting down through here. But what I'm going to do is to show you some close-ups of that. So this is from 2017, and they've sort of analyzed this stuff. These are sand waves. This is A here, and then we'll look at B and C. So there's our Paleo River Severn, and the sand waves, which presumably the sand was dumped out there, but then reworked during the transgression. And then go to the other two. There's our River Severn channel again, coming down through here. But over here, what you have is a moraine, or a couple of moraines. So this would seem to be where ice from that, the Devonian ice age has actually pushed material out, and you've got material dropped at the edge of the ice. So this, in the Devonian, this is as close as the ice got. And this gives you an idea. So that's where we were looking at there. The ice, the number 3 coming down through here is supposedly the late Devonian glacial limit going out through here. Earlier, it came up through, but it never really contacted the southwest. But the Anglian, the earlier, bigger ice age, the one that produced ice just north of London, diverted the Thames, that actually did come up against the edge of Exmoor. And if you remember from the Ilfracombe trip, one of the stops we went to was the Valley of Rocks, which is a suspended valley up in the middle of nowhere. And that is supposedly a product of when the ice was actually up against that edge. Also, 2022, the BGS started releasing detailed maps of the seabed in the Severn, right away across this sort area here. Now, that's Linton there, and the sort of Mineheads about there. So it's quite a way offshore from where we're talking about. But I want to show you a number of these pictures, 1, 2, and 3, because they are astonishing. If you haven't seen these, they are wonderful. So the first one is this one here, this area here. This is our channel running down through here, but this is a geological map. And this is a combination of high resolution bathymetry and the geology. So you've got lots of faults and things and that sort of stuff. And look at this. This is just astonishing. Look at the next one. It's just beautiful. And of course, what you're seeing there is exactly what we were looking at here. You're seeing that wave cut platform through these layers of rock and you're seeing these the faults and the folds. Back to that one. Just beautifully laid out. Lovely stuff. The last one I want to show you is this, which is further out, much further out. And what I wanted to draw your attention to here are these big faults mapped through here. And this is an important fault system running down the center of the Bristol Channel. And if you look at the map as a whole, you've got this central Bristol Channel fault zone. And that's what you were seeing there. This is, it's got a lot of colors on it and all that sort of stuff, but essentially that's our Devonian chunk. There's Ilfracombe here, and where we're going is here. Those are that's the Quantocks. That's the Severn Estuary there, Gower, that's Gower there. So you've got this basin through here, which is Jurassic and Cretaceous. And it's actually a rift basin and very similar in many ways to the Weald. So if we look at this, so this is a very recent paper, 2024, and it looks at some of the, what it does is it dates carbonate deposits, veins, carbonate veins that are associated with faults in this area. And you've seen there's a lot of faults. So there's lots of things to date. And we've talked about this before, I know, because the similar thing has been done down on the south coast to try and date some of the deformation down there. So there's the Bristol Channel Basin there, the Weald there, the Wessex Basin. There's a whole bunch of these sorts of things going through here. And what they've done, so you've seen these sorts of pictures before. These are the foreshores, and they've taken, there's the faults, there's the faults of different varieties. So this is normal faults here. These are sinistral strike slip and dextral strike slip faults. And there are also some thrusts. They had plenty to choose from, so they got lots of nice samples, and they used this uranium lead system to date when those carbonate veins were put in place. And this is the answer. So we'll start with, I'm sorry, that's off the top. That's annoying. But anyway, so these are the normal faults. So dates from the normal faults and also the Quantock head fault date from the early Cretaceous. This is the rift. So it's an early rifting phase, end of the Jurassic and through the early Cretaceous. So it's opened up, you've got sediments deposited in it, and then it gets squashed and inverted in the Eocene. And that relates to Pyrenean thrusting, not, as we've always said in the past, alpine thrusting. And this story has come up again and again. There have been workers in France, in a couple of places in France, who've been looking at exactly the same thing. This technique, once it came out with Parrish et al. In 2018, lots of other people have done the same sorts of things and found the same thing, that actually it's the Pyrenean deformation that starts all this stuff and the inversion. So, you know, you've got the Pyrenees down here, which is, it turns out, is doing most of the work. Later on, you've got the Alps, which may be adding something to it. You know, you can't dismiss them. And you also need to take into account the fact that there's the Mid-Atlantic Ridge over here, which has a certain push to it. or it's been modeled that it has a certain push away from it. So there's a certain amount of pressure coming in this direction as well. But, you know, the heavy lifting is all done by the Pyrenees. So going back a bit earlier, before the Rift Basin, I think you'll have guessed I'm working my way back down the stratigraphy. There's a question about whether or not there was ever actually a landmass in the middle of the Bristol Channel, whether there was a high there. And the key piece of evidence for this is that if you go to look at the conglomerates in the Hangman sandstones here, when there are some, they've clearly come from the north. There are conglomerates in the Woodhill Day formation up here, which have come from the north. Sorry. Whereas in South Wales, the conglomerates have come from the south. So off in that direction and off in that direction. Although there are plenty of sands and conglomerates also coming from the Welsh highlands. So this rather begs the question of whether or not there was something in the middle here which was shedding material to the south and also to the north. And if you take into account all of the thrusts and the folds that we know about through this area underneath everything that go back to the Variscan, you can put in 40 kilometers of land there, which could be upland. It's been called Britannia, which is frankly a bit pretentious, but the Bristol Channel landmass, and whether or not it's true, I'm not so sure. Other people have looked at this map, which is the overview of the Variscan tectonics, so that the thrust front for the Variscan, sort of beyond this, it's not really affected. Down here, it's all affected by the Variscan folding. If you go down through here, there's, you know, the lizard doing its things down here. You've got thrusts coming through here. You've got strike slip faults, which are later reactivated. And you've also got this thing called the White Bray Fault, which runs across the channel and into France. And people look at this map and they say, oh, look, we can just keep going through here and through here. And we know that there's a fault. There is later a rift through here. So lots of faulting going on. It's a weakness. So perhaps you've got something that runs all the way through there. The other oddity is that people have looked at the sediments and tectonic styles through here, and they don't really match anything up here. So what they do is they slide southwest England 400 kilometers south. This is a simplification of this same map. But they slide that and big chunk of France 400 kilometers south along this long strike slip, the White Bray, Bristol Channel Fault, whatever you want to call it. And what that does is you can then sort of line up tectonic zones. So the Rheno-Hercynian zone, southern limit is there. The Variscan structures comes through there. And, well, that's the other side of it anyway. And the suture, the suture where that original ocean closed, then kind of joins up through there, which kind of feels okay, except that when you look at this map, which I think is much more instructive, there's this bloody great hole with nothing in it. And that's because you've slid that down there, and there's nothing to fill this. So this is an ongoing discussion, and people come up with ideas for this, and I think we're going to get quite a lot from Dave Green on this while we're down there. So the jury is out.